Yeah, welcome everybody. And the topic of this was just a deconstruction of the Hamilton 21 Marine Chronometer. This is a subject that we could cover for many meetings and many hours. And I don't want to do that in this situation, but I wanted to sort of talk about the Hamilton 21. I consider it the, kind of the pinnacle of mechanical marine chronometers. It solved the middle temperature problem, performed admirably, was able to be manufactured in very large quantities and adjusted to 3 times the specified rate that the Naval Observatory had requested. And this could all be done by, really semi-skilled people that were brought into the factory and trained on the job. In the old days, you had adjustment experts and people who had watchmakers and fabricators that spend their whole lives learning their trades from guilds and other areas. So Marvin Whitney has written several books and a number of articles that have appeared in the NAWCC and AWI publications over the past. He worked for the Naval Observatory chronometer shop, and so he's had a lot of experience with military timepieces. He published his book on the ship's chronometer, which is one of several books that is worth owning. I think it has the most amateurish cover art, though, and rather amusing. The book covers multiple chronometers. Here's the contents page of it. Talks about the birth of it and some early stuff, and then how to handle it, how to disassemble, reassemble, oiling, adjusting, general repairs. Here's a picture of how, out of the book, on how the balance wheel is impulsed by the escape wheel. In a marine chronometer and a detent escapement, rather than having a pallet fork that is driven by the escape wheel that in turn impulses the roller jewel on the balance, driving it. In a detent escapement, the escape wheel drives the roller jewel on the balance wheel, and it impulses only in one direction as compared to both directions in a conventional lever escapement. And there's a spring device called a detent that controls all of this, which I didn't take a picture of. So anyway, we can talk about that later. These are reprints of the technical manual that the military or the Navy published for servicing and handling of the Hamilton ship's chronometer. The book on the left is the same as the book on the right. It's just slightly larger and printed on higher quality paper. You can also find, I think, all of this as PDFs online in various places. And if not, I do have a PDF of this that people need it. I can certainly upload it to Dropbox. And this is showing pictures of some of the steps that they go through. This one is particular thing is showing removing the hands and removing the balance wheel. So it's a step-by-step guide, and I kind of followed it when I took apart my 21 chronometer. So this is an outer box for a Hamilton 21. You'll actually find the same box design for pretty much all the modern marine chronometers. Even the Russian marine chronometers use the same box. It does have this kind of large tail on the side that allows you to clamp it to a desktop. So a navigator table, for example, might have this screwed in. Just a close-up of the label and the latch on it. So this is showing the tail, and there's a screw hole right there where it at one time was mounted in. They also have a leather strap that goes over the top. This one is missing a leather strap, but you see the screw holes where the leather strap would go over. And this is typical. This cracking is real typical in dry climates like Colorado. Our humidity during the wintertime is 4% inside, 10%. So things coming from coastal areas tend to crack pretty badly. This is the chronometer that I took apart. It's actually in a pretty rough both boxes are rough. Normally there would be a lid covering this, and you can see the hinge, half the hinge is still there. These have a pull-out pin, so you could pull the pin out, the hinge pin out, and remove the cover. And that was actually pretty typical. They'd pull the cover off, they'd let it sit in this bigger cushion box bolted to the navigator's table, and the lid got thrown in the corner someplace and eventually disappeared. So you see a lot of them without the lids. Close up of a typical plate. This one is plastic. You'll also see metal. And this box has suffered from moisture. It actually smells like the sea when you open up the big storage box. It has this kind of smell. And anybody, feel free to interrupt or ask questions at any time you want. So here's a close-up of the chronometer in the gimbals. You got a locking thing here that you can keep it from swiveling, and the winding key is up here in the upper corner. That's actually a winding key from a Russian chronometer. This is a picture of instructions on how to lock the balance. When you move a chronometer, it's best to have the balance immobilized so they can't move, and just a little bit of wind on it so that there's some tension in the escapement. All the gears and everything have some tension. Hamilton built some devices to lock the balance, and one of them is a big spring thing with plastic caps on it that can be screwed down through the back of the chronometer case with a special Allen wrench, and this comes down and touches on the top of the balance and locks it in place. So this is one that you could do without removing the chronometer from its bowl. This was the original Hamilton balance locking device, which was a simple little arm on a screw that you would swing around and capture the mean timing screw on the balance, the weight, and that would lock it in place. And I actually like this design the best, but you have to take it out of the tub, and you have to get this thing on the balance wheel without damaging the balance. And the Naval Observatory decided it'd be best if they could avoid that. And the very first Hamilton chronometers didn't even have this. They had nothing. And this particular chronometer that I take apart, it was perhaps retailed by NAWCC. You see them around there. They also have sometimes chronometers under their own name. You'll see out there, but I think they were Mercer chronometers possibly. So this is Ulysses Nardin chronometer. This is actually mounted on kind of a display ring that you will see that came out after Hamilton chronometers started hitting the public market after the war, and with the decline of mechanical chronometers when quartz replaced them. I show this because Ulysses Nardin was the granddaddy of the Hamilton and the Elgin chronometers. In the late 1930s, I believe, actually is June 26th of 1940, the superintendent of the Naval Observatory put out a request to all the American manufacturers to build a marine chronometer for the Navy. The Navy was in the process of massive shipbuilding, and they needed marine chronometers, and there was no marine chronometer business in the United States building these larger chronometers. During World War I, they were taking higher quality pocket watches and sometimes putting them in little gimbaled mounts, sort of like what we'd call torpedo boat chronometers, but they weren't necessarily dedicated detent chronometer escapement devices. They were just highly finished conventional pocket watches. So in June 26, 1940, the request went out to Chelsea, Elgin, Hamilton, Yeager, AR and J.E. Malin, Seth Thomas, the Ingram Company, and Waltham, requesting them to manufacture ship chronometers for what would become the world's largest navy. Every one of them, without exception, declined to participate. There was continued request, and in November of 1940, Hamilton relented and said, yes, we will attempt this. And at some point, Elgin did as well. So the Naval Observatory sent Hamilton and Elgin Ulysses Nardin chronometers like this one. The Naval Observatory had bought 5. They were being retailed by Wittenauer in the US. And the reason why the Naval Observatory chose Nardin is because Ulysses Nardin had won 1,800 chronometer trials over the past years with this particular chronometer design. And they were one of the first to use LVNR or NVAR in their chronometers, and they performed very well. The US wasn't the only one that copied Ulysses Nardin chronometers. The Japanese, Seiko, modeled their chronometer after that, and although Seikosha at the time, and so did the Russians. Although the Russians, they used a slightly different setup on how the Fusey chain worked, but we'll talk about that in a bit. So here's a picture of the Nardin chronometer. So this is a split balance between these two weights. There's a split on each side, and then these are mean time screws, which are for adjusting the rates. And these balances weights can be moved back and forth. There's screws on them, so they can be moved along this bimetallic arm that expands and contracts according to temperature and also centrifugal forces. And this style of chronometer looks very much like the Liverpool chronometers. If you put this one and a Mercer side by side, sometimes you didn't know what they were, you'd be hard pressed to know the difference. Same thing with the Russian chronometer. And that's just a close up of their logo on there. Another side picture of it. So this is the mainspring barrel, and this is the Fusey. And so the Fusey has got this tapered cone that this chain goes up on, and to try and equalize the mainspring forces as it winds down. On the Russian chronometer, they actually, rather than having this go straight across, they do what they call a reverse Fusey. This thing goes around and goes around on the other side of the Fusey and winds up crosswise. The reason for doing it that way is that with this setup, there's wear forces on these arbors, and they tend to ovalize in the direction of the mainspring. And when you do a crossover, they don't have as much force in that direction, and the holes tend not to ovalize in the same way. So Victor Kohlberg and the Russian chronometers, I believe, use a reverse Fusey setup. Another close-up of the balance, rather grainy looking. So now we're back to the Hamilton. So I'm showing, flip it around and unscrew the cover, and this is how you set the time on it. Use the winding key on the center of it, and you only adjust the time on these things in the forward direction. You never want to run it backwards. So here I just another close-up picture of the dial. So to get the thing out of the tub, if you're leaving it in the gimbal rings, or even if you take it out of the gimbal rings, putting the winding key on the winding arbor and then pushing it out into your hand is the way to do it. You can flip it over, and sometimes you'll just drop out by gravity into your hand, but not always. So winding key is a safe way to do it. And then you lift it out. Honestly, an easier way to really deal with these things, especially if you're going to service them, is to take the whole tub out of the gimbal rings, because I use the tub as a movement holder, and we'll see pictures of that in a bit. So here's my Hamilton, my victim, or however you want to call it, out of the tub, and you can see this balance locking device. So there's a spring arm that goes across. There's this Allen screw that pushes down. These white things are dust rings. They try and seal against the back of the bowl to limit the amount of dust. So you can drive this thing down, and there's nylon tips on both sides of this fork that push on the surface of the balance, immobilizing it. Another view of it from the other side. Some differences you can see. For example, on the Nardin, there was what we call a setup ratchet on the mainspring. You you don't wind the mainspring, you wind the fusee over here, but you put some preset wind on the mainspring even when it's fully unwound, and this setup ratchet does it. In the Hamilton, they've got this beautifully finished cover, this nice spring, and a pivoted ratchet on this fine ratchet wheel. And if you go back and look at the Nardin, you just see this little brass ratchet wheel and this click on a screw that you manually have to push against the ratchet as you adjust it. Some of the Liverpool chronometers will have a beautifully blued and flat polished spring that comes around to about here that tensions that. Having this kind of a setup is a bit of overkill, and having this fancy balance lock is overkill, but that's what the Hamilton ended up with. Beautifully finished plates with these horizontal stripes. We'll sometimes call them Geneva stripes. I honestly don't know if these plates are nickel plated brass or if they're a nickel alloy. I don't know that off the top of my head. There I'm showing, you've got this rotating dust cover on the bottom of the chronometer bowl. And so with these modified, or these Hamiltons with the fancy balance lock, you've got two holes in it, and one hole gives you access to that Allen wrench or the Allen screw. And then this is where it's opened up to the winding position. This is a different chronometer in my collection. You'll see these are called brake circuit chronometers. And what they've done is they've added switch and a wheel with bumps on it that works a switch. And so they use the chronometer to provide accurate timing signals. And back in the day, before we had telemetry recorders and tape drives and now solid state discs and all of that, you would often record things on strip charts. And if you wanted to have an accurate indication of when things happened on some strip chart, you would hook up a brake circuit chronometer to one of the recording pins on the strip chart, and you would get these regular impulse marks depending on how you chose your timing signals from the chronometer. You could get a 1 pulse per second, you could get 1 pulse per minute. It varied depending on use. So these were often modified again in the Naval Observatory to this function. So we're showing some of the connections on it, and this is the bottom side. So you'd put in 4 D cells, and then there was a relay that would isolate whatever it is you're driving from the chronometer, because you didn't want to necessarily damage this fragile switch within the chronometer. This is a performance certificate that actually happened to come along with this particular brake circuit chronometer, some notes on chronometer performance. So this is an actual Hamilton key. So it's got this different shape to it. And then this is a little auxiliary Allen wrench tool for locking the balance. And that's what it looks like. These are the connections to the brake circuit on this particular chronometer. And you show these fabric covered, highly flexible wires that allow it to still gimbal if necessary. So this is the connection to the switch, and the other side of the switch is actually just connected to the tub of the chronometer. So this is the switch down below here. This is actually the 4th wheel. And this particular star-like ratchet wheel on the top, that's what actually drives the switch. The switch is based on another detent spring, basically. And so I'm guessing this thing impulses, maybe once a second or maybe twice a second, and another kind of attempt to show it, although it's not focused very well. And this is how the Allen wrench works inside this locking tool. So here, don't know how well this will play, but so are you seeing the balance wheel going in slow motion?
Yes.
You might even be hearing a tick, maybe. So this is using iPhone in slow-mo and showing the balance going. The balance actually swings more than 360 degrees. If you follow the arms, it rotates quite a bit. And this is showing the escape wheel, although it's probably, you can see the detent, there's a black looking object right here. This is what we call the locking jewel. So that actually blocks the escape wheel from moving, and it moves the detent spring when it comes back, and it unlocks the escape wheel, and then the escape wheel teeth hits the roller jewel and impulses the balance in that one direction. Another attempt at showing the roller jewel down underneath, or the roller table. And so to take the chronometer apart, you first have to stop and remove all of the tension off of the escapement. If you try and take a chronometer apart while there's power on the train, if the escape wheel starts spinning, you bump the detent and you move the locking jewel away, and the escape wheel starts to move, starts to spin more than a couple teeth, and then you let the locking jewel come back into place. It will shear the locking jewel right off because it's a ruby usually. Sometimes they're replaced with hardened steel, but you'll either break the locking jewel or it'll actually break the detent itself. And detents are expensive and hard to find, and in some cases you have to make them if they're an antique chronometer. So normally, to stop the escapement, they block the fourth wheel. So the fourth wheel is the wheel that's driven by the escape wheel, and that's also got the second hand coming off of it. And Hamilton included a screw in most of their chronometers that actually goes through the escape wheel bridge, and you can lower it down and block the arms of the fourth wheel. In this particular chronometer, somebody took the screw out and didn't replace it. So you have to do a different technique where you form a wire hook, and you're going to hook the spokes of the wheel to this particular pillar. And so I'm using some 22 gauge spring brass that you normally use for, making little springs and clocks and stuff. And I bent it into a hook shape that I will then hook around this pole and get into this, lay it onto the wheel. And then with the chronometer under power, you start the balance swinging, and then you get it to eventually snag and seize up the fourth wheel, and it stops moving. And if you use the screw that comes down through this bridge here, you have to make sure that you put it down between the spokes. If you try and drive it down on top of the wheel, you'll destroy the wheel, obviously. In the case of the Elgin, they did a really slick thing. They put all the escapement on one assembly module, and you can remove that assembly module with 2 screws. And when you do that, when you remove the screws, it automatically blocks the fourth wheel. It has some spring-loaded arm that comes up as the mounting screw is taken out, and it removes the power from the escapement, so you can take it all out as one assembly. In the case of the Elgin in Hamilton 21, supposedly, according to Whitney, all of the parts are interchangeable other than the escapement parts. And I actually don't know that for a fact because I've got a bunch of Elgin parts, so I might give that a try. So now I'm starting the disassembly, and first thing I'm doing is I'm going to take off this balance wheel lock because it's in the way. So you take the big screws off the pillar and the little screws off the thing, or off this whole the shell, and it comes off. And that's showing the bottom side of it. Again, it's a fairly complicated, little bit. And I kind of went out of sequence here. I'm starting to take the balance out, but I haven't undone power on the mainspring. And if you follow that service guide that the Naval Observatory published, you're supposed to remove all the spring power before you start taking the balance out. And I kind of got ahead of myself here, but you show it anyway. So the balance is stopped, and the hairspring stud is right below this screw here on the bottom side of the bridge. So you undo the screw, and it just naturally falls down, and it becomes hanging free. And there it is, loose. couple little pins that go into these holes there. And so then you take out the balance cock screw, and you can loosen up the balance cock. It's probably better to use your fingers. I didn't have my finger cots on, and so I used these tweezers. So you're supposed to grab the balance shaft, pushing the spring a little bit out of the way with tweezers and holding this in position while you remove the balance cock, and then you can carefully remove this out of the way. You have to be careful that you don't catch the detent, because again, you can bend the detent if you snag it. The detent is right underneath here, and this is the screw that holds the detent in where my cursor is circling. Dave Cooper, his recommendation is you actually take the detent out first. He says that's the first thing you do, and that way, if anything happens and the escape wheel starts spinning, it'll just hits the roller jewel on the balance wheel, and it knocks the balance wheel out of the way, but it doesn't break anything. But the detent is kind of around a bunch of stuff. You got the escape wheel and the bottom side of the balance wheel that it engages with, so you have to be careful about getting it out. So anyway, here's the balance wheel off, sitting on a little roller ring. We have these weights on it, go around for adjusting the rate, meantime screws here and here, and then some fine adjusting screws here and here. Comments on the Hamilton balance, which I didn't cover earlier. The balance rim is stainless steel. The hairspring is Elvinar, which Elgin had, or Hamilton had the rights to, and the arms are Elvinar. So Elvinar does not change much with temperature. It's very temperature stable. And the original chronometer specs that the Naval Observatory put out were written in the late 1910s, like 1918 or something. And it specified split rim balances and steel hairsprings. So it was a bit of an obsolete specification at the time that Hamilton designed this chronometer, and they asked for an exception to the rule, and they got it. Now, how the Hamilton balance works and why it works so beautifully is that with heat, the balance rim expands, but because these arms are silver soldered to the rim, it ovalizes. So this middle part on both sides between the arms spreads out. And the hairspring, being Elvinar, doesn't change with temperature, its characteristics. So it's very stable. And they were basically able to, by moving these screws, they had 24 holes drilled around the rim. By moving these balance weights around on the rim, they could get the mid-temperature balance correction done extremely well. And these weights here, they're adjusted in and out to control the base rate. And they had a special little screwdriver that had a round shell with a bubble filled with fluid with a little bubble in it, and then markings around the rim of this round bubble level thing that is along the axis of the screwdriver. And so they could look at this bubble floating to the top of this plastic disc, and it had graduations on it. So you can adjust these things in partial turns. And so one full turn of this thing adjusts the rate by about 1.5 seconds a day. One full turn on this thing adjusts it by like 1/10 of a second. And then if you use this bubble level and go by fractions of a turn, you can adjust this thing using this fine weight to 1/100th of a second per day, potentially. So it's easy to adjust. And then here's the bottom side. And so that's the roller impulse jeweled there. There's another little jewel in here, which you can't really see. And that's a jewel that basically pushes the detent out of the way and allows the escape wheel to unlock. And the balance wheel is held on with screws to a hub on the balance shaft. And on the bottom of the arms, you'll see the serial number of the chronometer scratched on them. Now I'm going to releasing the power. Normally, the process in that the repair overhaul guide says you wind all of the fusee chain onto the fusee, and then you release the mainspring power using a letdown key, and you have to release this little click here. So I tried winding the chronometer up with it out of the tub, and I found that I couldn't get enough twisting force on it. The spring is so powerful, I couldn't really get it to wind up without it wanting to twist on me on the workbench. So I said, I'm not going to do that. I'm instead just going to release whatever power is in the mainspring with most of the chain actually on the mainspring barrel. So you can see there's a fair amount of chain on the mainspring barrel. And even trying to do that with the letdown key, I found it impossible to do. So what I had to do was put the whole chronometer movement side up in the tub. So I've got the movement on the tub, and I'll show you a picture of that and hold it between my legs so I could clamp it hard enough. And then I could turn this thing clockwise to release tension on the click, and then pull the click out of the way, and then slowly let the power down with this letdown tool. So this is a letdown tool. It's smooth. Never use a chronometer key to try and do this because you can't do it carefully enough. You can make handles for your chronometer key. So you take like a wooden broomstick or a big dowel, drill a hole the size of the body of the key, and then cut a slot in it, a wide slot, to take the handle, and you can use that as a handle for your chronometer key. But in general, these clock specific letdown tools are much better. And just as an FYI, a number 3 is the size that seems to fit. So what I did is, so I'm just showing it there. So now what I did was I've gotten the fusee chain all wound up on the fusee. Again, I held the click out of the way, and I put the letdown key on the fusee, and I wound it up. So the mainspring, the whole barrel was rotating freely as I wound up the chain onto the fusee. And then what I'm doing here with the tweezers is there's a ratchet wheel above this gear teeth here, and the ratchet wheels for what they call the maintaining power. There's a maintaining spring sandwiched between these two levels of the fusee. And when you're winding up the clock, you're winding this, but the maintaining spring is still providing power on these teeth. So it keeps the chronometer running while you're winding it. And Harrison actually developed that. But you have to release that because there is still tension on the train. And if you pop the fusee chain off, but you don't release the maintaining power, and then you start taking things apart, you can still break your locking jewel. And that's not an uncommon thing that clock makers will do when they want to do a quick clean and oil on these things. So you got to be careful about it. And now all the tension is off everything. And so you can actually pry off the end of the hook that goes into the mainspring on the fusee here. So I'm just prying it out with a jeweler's screwdriver, and pop, and it comes off, and there's still a little bit of roll in there. And then you flip the chronometer over and you start taking the stuff off on the dial side. So here I'm just pulling the hands using this little gear puller. And actually I could have just pulled these off with my fingers because they were loose enough to do that. But I used this to take the hands off, and I also used it to pull off the power reserve indicator. And then I used a conventional watch hand remover to take off the second hand and use a dial protector to protect the dial. So there the hands are off. Then you flip it over, and here you can see how I'm using the tub as a movement holder. So the dial is held on with 4 screws on the back side on this brass rim. So you loosen those up, and then you're supposed to hold it in the palm of your hand with a piece of tissue paper, and you get all the screws out. And then on one side near the balance wheel, there's a notch in the dial rim, and you can put in a screwdriver or a piece of pegwood or toothpick, and you pop the dial off. In my case, all the under dial gears came out with it, but here I put them back on to show you how they look underneath the dial. So this is a power reserve indicator, and it's actually just driven by the fusee. The fusee is really a great thing for power indication because it basically moves as the spring winds down, and so you can just reduce it and get a partial arc, for the wind status of the clock. And then of course we have the hour wheel and the minute wheel there, and here they're pulled off, and we've got the cannon pinion there. So there's all the parts. These are the 4 screws that hold the dial on. And now I'm pulling this guy off, again, using my little well-used gear puller. Fortunately, I didn't have enough length in it to get it all the way off, and this particular thing was still stuck on there, so I had to find a little steel collar and then use a couple levers to get the final thing lifted off. So once you've gotten all those screws off, you then flip it back over to the movement side, and we're looking at the top of the escape wheel bridge. And so you take the escape wheel bridge off, and there the escape wheel bridge is off, and there's the escape wheel sitting loose in there. And we're looking at the top of the detent here. So this is the bottom of the balance wheel. The lower balance wheel jewel. Maybe it's the upper, I don't know how you call it in these things. So there's a locking jewel here, and there's a spring back in here that you can't see, and there's a spring here. So this is what they call a passing spring. So when the balance wheel is swinging counterclockwise, the jewel that trips the detent hits this, but it passes, it allows it to pass. So this spring flexes, and that unlock jewel, or that impulse, not the impulse, I'm losing my terms here, but that jewel passes, but the detent doesn't release the escape wheel until it comes back around this way, and then it hits the spring on this side, and there's a arm here that holds the spring, and that causes the whole detent to move in this direction as it comes back around clockwise, and that pulls this jewel away from the escape wheel, and then the escape wheel can move 1 jewel and impulse the balance wheel. So there's the escape wheel out and the top escape wheel bridge. And again, we're looking down at the detent, just another view of it buried down underneath the plates.
I would have to, sorry, I just have to remark that is a beautiful pivoting job on that escape wheel. Wow.
Yeah, they are nicely finished. You know, they're finished like it's like balance wheels. You know, they've got that same finish, and they are capped also. This is the detent block, as they call it, right here, and this is the escape wheel bridge. And so they say, you know, use a wedge, and they give a tool number, but this is actually just a piece of sharpened pegwood that you jam under there, and that just forces the detent back up against the plate, so that you can take the screw out right here, and then you pull the pegwood out, and then you can grab the whole detent block assembly and pull it out. So again, there's this, I think they call this the passing spring, and then the main detent arm is here, and then there's some adjustments on both how far this goes in and how far this is positioned in this direction as part of the whole detent setup. So, and then we're going to take apart the setup ratchet bridge and pull that off, and this in the setup wheel they're down here, and then you take off the winding dust covered arbor, whatever you want to call it, and there's a spring and another collar here that's to help keep dust out of the movement. And then you can pull off the screws, pillar screws on the mainspring bridge, and pull that off. Here the fusee chain has fallen on the outside of this pillar. So this comes off. Now I did find that the screws holding this bridge on, and the motion works, or the main, not the motion, but well, I guess the motion works. The screws were really tight. And again, I had to use a lot of force to get this off. And what I found I had to do was put the screwdriver, the large screwdriver, in the slot and push down and hold the screwdriver firmly, and then rotate the actual whole chronometer assembly. And I've been told this by other watch and clock makers, that sometimes when you got a really stuck screw, rather than trying to twist the screwdriver, twist the thing holding the screw. And so it's a whole lot easier to just with all your might, keep the screwdriver in the slot so it's not going to come out. So here's the bottom side of that bridge. This is a Fusey stop screw, and I'll show you how that works in a moment. And that's the top side, and I still have the ratchet spring on there for the setup. And in the disassembly manual, they take all of the stuff out. For you and I cleaning it, you don't have to do that. I mean, you can leave these springs on. I think you just have to make sure you get things dried out. This I'll probably clean in water-based clock cleaning solution. So maybe I will take that off so I don't get trapped water rusting the screws in there, actually these aren't held in with screws. These are just held in with these two locating pins. But a lot of people clean these actually in watch cleaning solutions or solvent based clock cleaning solutions. So here's just showing the mainspring barrel and the Fusey again. So then you take out the mainspring barrel. And in this particular chronometer, all the oils had actually set up, and it was actually very difficult to lift the barrel out. It didn't want to come out. I actually had to rotate the barrel back and forth while I pulled up on it, and I eventually was able to get it out, but it didn't just lift out. You can see a little bit of grain on the end. Nice thing about the Hamilton mainspring is that the cover is held on with 5 screws. All other chronometers, at least the European and the Russian chronometers, it's a snap cover. And so this is actually held on with screws, so it comes apart very easily. And I'm not going to go through taking apart the mainspring in this example. So here's a Fusey chain. This is the Fusey Stop Bar. And what happens is that this bar is in the track of the Fusey chain. And as you hit the end of the wind, the chain pushes on this and pushes this in and extends it on the other side out, and that hits that stop screw. So that's how we prevent you from overwinding it. And so again, you have to pull a click, which you can't really see underneath here, out of the way. That's the click that goes on the maintaining power ratchet, and then you can lift the whole Fusey assembly out with the chain on it. And then they say, hang the chain over a piece of wood. I see people roll them up on wood, so this is a big piece of pith wood that I've rolled it up on. This is a hook that goes in the Fusey side, and it's got a sharp angle on it. You cannot remove that very easily if there's any tension on it. And then this is the mainspring barrel side. So it's got this tongue hanging out, and you can lift it out of its slot using that. Here we're showing kind of the chain grooves. This is the little pin that the Fusey hooks onto. And this is the bottom side. This lower half of the Fusey barrel is held on by a taper pin, and so you push the taper pin out. This is the top side, again showing the Fusey locking stop bar that goes through there, and I'll show that with the cover removed. So now I'm removing the train bridge, and I'm showing a bunch of grease in there. I got the screws out, and again I had to put the hold the screwdriver down with a lot of force and rotate the whole movement on the bench. And I couldn't lift the plate off. It was glued in with this hardened grease. So in the end, I got it off, but these 2 gears were stuck in it. And so it took a little bit of effort to get them off. And then this is the bottom side of the escape wheel and balance bridge right there. And now we're looking at the bottom side of the dial plate. This is the ratchet for the maintaining power, and so it's got a straight spring that fits in a hole on the upper plate, and then the pivot there. And again, looking at the bottom side of that bridge, top side of that bridge. This is the dial side bridge. I'm just showing these 2 screws on it. Those are actually posts for the wind indicator and the minute wheel, and that's kind of nice because they're screwed in. In a lot of cases, they might not be screwed in. I think on the Russians are possibly pressed in. I think on the Nardins, they might be screwed in, but there's like a flat wrench spot on the top side. I've taken the bridges off there, train bridge off. Now I'm removing the cap jewels, and these are all marked. So in this particular cap jewel, there are 4 little divots that are marked down in that side, and there's 4 little divots on this side showing that this belongs here. And that's done partially to also deal with end shake. These things can be adjusted a little bit in terms of how they depth, and this jewel in this hole here can be adjusted a bit. And so you want to keep these things together. And so normally if it's been serviced, they'll be marked. And if they're not, haven't been serviced, they won't be marked, and you have to mark them or keep track of them yourself. Now I'm showing this taper pin, and I pushed this thing out and actually used a little bench vise to push that out by squeezing, holding it at an angle on the vise and closing the vise and pushing the skinny side out. And so now I've separated this assembly with the maintaining power from the actual ratchet wheel, or the top of the fusee. So this is the winding ratchet right here. That's the gear that drives the power reserve indicator. And then we've got two little ratchets here, ratchet clicks, and then brass ratchet springs. Here I pulled the cover off the stop bar. And again, the fusee chain, there's a little spring here holding this bar out in this direction. And the fusee chain comes around, pushes this bar forward in this direction, and it hits this screw here, and it can't go any farther. A close-up of the spring. This is probably pretty seriously over lubricated. And now I've separated these two halves, and this is the maintaining power spring. So it's got a bar on this side of the spring that engages in this hole here. And you can basically, when it gets wound up, it just gets tensioned a little bit and can provide enough power to keep the chronometer running while you wind it. So here's all the bits and pieces. I haven't bothered counting them, but you can see them all in their respective trays. So I had anticipated that I'd just take this chronometer apart and then put it right back together without doing anything. But after encountering all the hardened grease in it, I think I need to really go through the process of cleaning it. So I'll probably run all the small parts. I have a Tempo 400 watch cleaning machine, and I'll use watch cleaning solutions on all the parts that will fit in the Tempo. And then the main plates, maybe I'll do them in an ultrasonic cleaner, but with watch cleaning solution rather than water. I haven't decided. Now, I haven't taken the pillars off or remove this from the dial ring. But if I pull these, there are screws around the periphery, I can pull this plate off this brass ring, and then I can also remove these pillars. They should also be marked to location. So they suggest, again, that you make scratch marks or divot marks to make sure you get the pillars back in the correct position. So I will stop sharing at this point. So any questions, you guys, on all of this? I've rambled for an hour plus.
Around what time did these kind of fall out of vogue, I guess?
I think probably in the 70s is when mechanical marine chronometers started. Well, it was with quartz, so it was late 70s. So it'd probably be late 70s, early 80s when things were starting to be replaced with electronic technologies, and the mechanical chronometers were becoming less common. With glasnost in Russia, huge quantities of Russian chronometry equipment came on to the American and Western markets. And Dave Cooper talks about going to the nationals in the 90s, and people would be pushing, the hotel carts that they used to load table stuff on and wheel them into the table. And these hotel luggage carts would be packed to the top with chronometers, and they'd be pushing them in, and they'd be like falling off even. There's just so much stuff that came out. Hamilton chronometers are the price points of them are somewhere between 1,000 to 3,000 or more, depending on condition, provenance, and some other things. You can get Russian chronometers for 500 to below 2,000 pretty easily. They're really common.
One of the things that I would love to do is eventually make a watch kind of based on those chronometer movements, except it'd be much smaller. It'd be a wristwatch,
Right.
except it would be mounted in a gimbal in a square wooden box.
So you do
It's
a
also
little miniature
serviced.
gimbaled chronometer. They're actually, you see some watch chronometer based miniature chronometers out there. I've actually seen them on eBay in the distant past, nothing recently. And there are chronometer escapements in wristwatches. The resurrected Urban Jorgensen, the Jules Jorgensen company.
Yeah.
They have a patent on a detent design for wristwatch that everything is kind of counterbalanced so that it can work well in a wristwatch environment. Because the balance is only impulsed in one direction and it's a big balance, they tend to not be super tolerant of impacts that you might get on in wrist use. So there are some tricks to making them work. And then people have also done small detent pocket watch conversions into wristwatch cases. I've seen those in the past.
Yeah, I mean, maybe you already talked about this at the beginning, but I was just curious how long you had this particular one before you decided to tear into it. Was it like a recent thing, or have you had this sitting around kind of waiting in the wings for a while?
I've had it waiting in the wings for a while. I actually don't remember when or where I got this. I have a number of Russian, American, and European and English chronometers. I don't remember where I got it from. I have to go back to my records. So it's been sitting around for a long time.
Okay.
I've serviced I think 4 chronometers in the past. I did a Ulysses Nardin that I came out of Japan that had a broken center wheel shaft. The hour minute hand shaft was broken, so I had to redo that. Done a Glashute GUB, Eastern European. I've done one that had a cable in place of the Fusey chain, and I think I've done a Mercer chronometer as well. I think I don't remember. And again, these things are simple. Tear apart, clean, simple repairs, put back together. On the Nardin, I also had to rebush the mainspring barrel. That's right, because the mainspring barrel was badly worn. But if I had to do anything in terms of adjusting the detent escapement, I couldn't do that. I don't have the skills to do that.
Okay, no, that's cool. So you've had it a while, but maybe not as long as the people who were loading them up on the hotel carts.
That is correct. Yeah, there's those days are gone. You still see chronometers at all the nationals and a lot of the regionals. Chronometer boxes are often missing or can be in bad shape, and there is a guy who does rebuild and make chronometer boxes. I think he's based in Salt Lake City. I've met him in the past, and Dave Cooper has used him to make some boxes for him. The Russians are the most common, and the Russians are really good quality chronometers. They shouldn't be discounted. Some of their construction techniques are a little different. Some things are pressed in where they might be mounted with screws and other chronometers makes. But the Russians, I believe, had this requirement that they wanted mechanical chronometers on anything that needed navigation as a backup to the electronics in case of the electronics get taken out by EMP from a nuclear blast, from what I've been told. At the time of Hamilton had quartz, I think a quartz master clock when they were doing these marine chronometers, but it was a 19-inch rack mount. It was like 1 or 2 or 3 bays, of rack mount equipment, vacuum tube kinds of oscillators and dividers. I'm going to continue screen sharing. Beyond the slide, I had this I wanted to show off. This I bought off eBay. This was a box that was used in the factory to hold balance assemblies, or it might have also been used to go between repair depots. So this is kind of interesting. It's in a ratty cardboard box, but it's got this 2-piece plastic tray or this tray, and it's got these little covers that screw on that can clamp down a balance wheel and hold the hairspring as well. And this is Bert Tolbert's Hamilton 21. It's actually a pretty nice one. It's an fairly early one as well. Comes in, it's double boxed and is got in quite nice condition. Yeah, that's actually not part of that. The box is in really good condition compared to the one that I had. Here you can see the wedging, a way that you would wedge if you didn't have some sort of stop assembly. So this is a little tapered wedge that Bert had made. I'll actually just use wax tissue paper and fold it up a few times and stick it under there without a whole lot of force. You just have to keep the balance from moving. It doesn't have to be held in with great force. I think it's more close-ups of his movement inside of the tub. When you shop for chronometers, especially Hamilton chronometers, you'll often find overhaul notices on the inside of the bezel, get to a bezel. So right on this polished inside surface, they'll stick on a paper label and it'll give the number and it'll have a service date on it. And you'll sometimes find that the bezel number does not match the chronometer. And it turns out that there's a lot of places, different contractors doing service on these marine chronometers, and especially with Hamiltons. And what they would do is when the chronometers would come in, they would take the chronometer out of the tub and just throw the tub and the bezels into a big box full of random bezels and tubs, and run the chronometer through the service line, and then grab a random tub and a random bezel and put the thing back together and send it back out. So that's not uncommon, and you don't have to, I guess, stress about such things. It's just what happens.
Yeah, that stuff doesn't surprise me. Although, I mean, it both doesn't surprise me, but then every time I hear about it, right, with these like high precision, usually, military, or at least, somewhat egalitarian pieces, that, yeah, there was just, they just didn't care about it back then. As long as it was a functioning piece, it didn't make a whole lot of sense to make a big fuss out about keeping everything together the way that we would now.
That's absolutely true. I mean, Tim Orr's got a A13 navigation watch that's got a Waltham movement and a Hamilton case back. But they all had the same case made by Star Watch Case Company or something like that.
Yeah.
For us modern collectors that want total authenticity, if that's an issue to you, then you obviously have to look and buy only what is correct for you.
Yeah, I sometimes think about that when I'm finding, when I'm looking for vintage military stuff. You think, oh, that one doesn't have the correct hands on it, or that one's got the wrong case back on it, or something like that. While technically true, it might actually be, not that you'd ever be able to track it down in a lot of cases, but it might actually be a more interesting piece if it is mixed and matched, because it's proof that it lived some sort of life.
Yeah.
And like you're saying, it's maybe just as authentic as something else that's technically correct. There's not as much of a separation there, especially with military pieces. Maybe with other things that weren't as used hard, or weren't as intended for service use or whatever. Fancier things might have something along those lines. In something that was more fancy, it might actually lead to inauthenticity or some less than, or what do you want to say, non-scrupulous practices. But with military stuff, maybe it's just the nature of the pieces themselves.
Yeah, the big concern that I think modern vintage collectors worry about is somebody building a showpiece watch out of other watches. Have they gotten 5 military wristwatches, and have they pulled them all apart and built 2 really nice ones out of that and selling them as authentic, and then selling the other ones for a lesser amount? That's just one of those things. In the Omega world with the Speedmasters, it just goes nuts there, because Omega had service hands, service dials, service bezels. You'd send a watch in for service, and if you had a ratty bezel, then they took off your ratty original and put a replacement service bezel on. And down the road now, all the people going, oh man, it's not perfect. So that's what it is.
Yeah, like I think you put it nicely in that you sort of have to just decide. It's such a personal choice. You have to decide what it is that's important to you, and then you have to do your best to sort of do your research and figure out what each one of these pieces, if it adheres to what's important to you.
Yeah. And of course, there's endless resources on YouTube and other locations, Instagram and Military Wristwatch Forum covers, I think, these larger mechanical things as well. In the realm of marine chronometers around World War II, you'll also find the German ones, Wempe and GUBs. As the war progresses, brass became a more important material for them. So they started making chronometer cases out of Bakelite and other kinds of proprietary plastics. And even the movement plates on some Wempe chronometers are plastic, and the basic movement itself is kind of shrunk down into little square plates that are still metal, and the chronometer are highly finished. They're very well done, but the actual dial plate and is holding this little square movement plate, and everything else is plastic. And unfortunately, some of these things haven't survived very well, and while they look less expensive, they are actually potentially, rare pieces these days because they didn't survive due to lack of interest.
Mhm.
You'll also find, trying to remember the name, Glashütte. Glashütte made marine chronometers, and for the Fusey chain, rather than a chain, they actually use a ribbon of stainless steel that winds up. And so you'll see those, and other manufacturers also experimented with ribbon materials to replace a Fusey chain. The Fusey chain is zillion little pieces. They're a pain in the ass to deal with.
I wondered, Tim, what could you tell us about the whole business with the inner box, the outer box, and the overcoat stuff?
What can I say? The on Bert's box, let me get back to that. If you look at the outer box, notice where the hook is and where this rotating latch is. This thing flips up and there's a little pin on this that rotates around and holds that in. Compared to the one that I had, they are inverted, and I'm thinking that the one on mine is actually a Russian outer box that somebody put a Hamilton label on. Pardon me while I get to that.
Did they have somebody at the watch manufacturing factory that made these boxes, or were these boxes made by another third-party company?
They're made by a third party. Yeah, so if you look at this one, the hook and the rotating knob latch are inverted, and I don't know if somebody just flipped it over, or if this was actually a Russian one. In terms of the boxes, they came from a third party manufacturer, and I actually have several of the inner boxes uncut that a guy on eBay sells occasionally. He usually does a starting auction of $25 on the box, and so I would just do a $25 snipe at the end of the auction, and I got probably 4 of them, thinking that I'd cut them apart and on a table saw and turn them into chronometer boxes. But it's a little more complicated than cutting them apart, because you have to actually route a slot, because they have these brass plates that go around each of the decks, that levels that sort of engage in a slot on the next one above to keep it from warping and breaking and misaligning. But there's a lot of the stuff came from third parties. So the Hamilton and the Elgin boxes, outer boxes, they look really pretty much the same, identical. Even the detent in the Hamilton 21 chronometer was actually made by some guy in the Midwest who, using a Bridgeport lathe, developed a technique for cranking these things out. And I don't know if Hamilton had problems getting them made or what, but there is a story in the NAWCC bulletin about the man that saved the Hamilton 21 chronometer. They supplied him with a Bridgeport that he put in a workshop above his garage. They had to take the mill apart and carry it up in pieces and then reassemble it, and he cranked out the detents for him. So I think there's a lot of smaller independent contractors, part of this effort to supply the chronometer industry in the US at the height of the war. Hamilton was making more chronometers in a month than what had been built prior to World War II in history. There are only a few hundred hundreds of chronometers made, leading up to World War II. And at the peak production, Hamilton was cranking out about 580 chronometers a month from their factories, all being timed and assembled by housewives that were pressed into service because, all the men were in war service. And Hamilton had built a lot of tools. There's pictures of it that I collect and do yet another presentation on these things. Again, I just sort of wanted to do this as a quick, let's take this thing apart. I didn't have a whole lot of time to really prepare for this. And I never prepare very well for these things anyway. Any other questions?
Are you, you said you were going to clean it, or to see how just the cleaning sequence, because like you said, you're actually, maybe some of those parts are too big to go in a typical watch, a watch basket. And so for a long time, I would just put watch cleaning solution in my ultrasonic cleaner and just very neatly kind of arrange the baskets and stuff before I got, a watch cleaner specifically. So I don't see any problem with doing that, but it might be cool to watch, to see how you go about doing that and re-oiling it and stuff. This is sort of, part one. It's like how to take it apart without destroying it. And then part two, how to service it and get it back together without destroying it.
Yeah, I can certainly do something like that. The ultrasonic cleaning in a tank with watch cleaners is something that I've done quite a bit, and I actually still do. I've got some of these solo lube and duo lube rinses that you're supposed to be able to clean your watch movements or clock movements assembled and lubricate them. It basically puts a plastic lubricating film on everything, and so I do those in an ultrasonic cleaner. I just have them in pill bottles that I have an abundance of, and so different solutions in different bottles, and I put those bottles in a small ultrasonic cleaner tank with water, to couple the energy. And that's what most people will do, is they'll have a cleaning tank that they put their watch cleaning solution in, and then put that tank in turn into a water bath in the ultrasonic tank, and then couple it through the water. And that way you don't have to worry about cleaning your tank out between solutions, wiping it out and stuff like that. In a lot of books, there are a lot of people, purists, that are concerned about the damage that ultrasonic cleaners can do if they're too powerful to things with micro stress cracks in them and such. Antique brass clocks, that's a concern for some people. Ultrasonic clean with something with ammonia in it, and it causes stress cracks to get worse, supposedly. All right, what else? Anybody? Or shall we pull the plug on the meeting?
It opens up. I've always been interested in chronometers, but it's like the hurdle to get into them is usually big enough, right? It's usually $1,000 or a couple $1,000. So I've never really jumped into it, but I've been thinking more and more about it. So
yeah, I was going to say, the other thing is it's a whole different ball game with chronometers, because amongst other things, some people have been dismayed to find out that a chronometer is not necessarily a good timekeeper. What they are is consistent rate. When you're at sea and you're trying to find your location, if you know that you're gaining a second a day or something like that, you just compensate for it. But over time, you find it disappointing, perhaps, that the timekeeping is not what you could have gotten from your $15 quartz watch from Walmart.
Thank you for showing up.